1 equals 2. Now, if I told you this, you'd probably think I'm joking, call me crazy, or tell me to stop running a math YouTube channel. However, there's a completely normal proof for this, with nothing suspicious. Obviously, right? Let me show you. Now, let's start off with one simple, harmless assumption. A equals B. Now, we're going to mess around with this a little bit, but we're going to remain in the realm of simple, basic algebra. Now, pay attention very closely. We're going to square both sides, so a squared equals ab. Then, we're going to subtract b squared from both sides. And we're actually going to factor both sides, so the left side is difference of squares, and the right side we can take out a b. And then, we're going to cancel out that a minus b in the parentheses. So a plus b equals b, but we established earlier that a equals b, so b plus b equals b. But then we get 2b equals b, and then divide both sides by b, 2 equals 1. This is a crazy conclusion to come to, but we did everything right. That means the proof is complete, 2 is equal to 1. But hold on a minute, there's more to this. Now, let's look at the step we trusted a little bit too much and got confused as to what it actually was doing since we were working in variables. After we factored, we decided to cancel out the a minus b on both sides. But wait a minute, if a and b are the same number, a minus b is 0, and by dividing both sides by that, we did division by 0, which is completely illegal in mathematics. So no, 2 is not equal to 1, but this holds a larger message as to how we should be looking at proofs. So I'm going to show you one last, more visual and more fun proof really soon, but why is that so dangerous, what we just did? Well, 0 times 2 equals 0 times 1, which means 0 equals 0. However, when we cancel those zeros, we get 2 equals 1, which isn't true, and which is why we can't divide by 0 in mathematics. It just gives us false results. 0 destroys information and gets rid of it. You can't just cancel it back like that. That's how silly mistakes give us contradictions. But don't worry, there are still plenty, if not more, visual proofs that can fool your eyes too. Here's a really fun one. Here's a fake visual proof that pi equals 4, even though we know it's approximately equal to 3.14. Now, draw a circle, and that circle has a radius of 1/2. So we can solve for its circumference as 2 pi r, or just pi. Now if we draw a square outside of the circle with the same side lengths as the circle's diameter of 1, we can solve for its perimeter as 4. Now we're going to take that square, push it in on the sides, and turn it into kind of a staircase that has a length of 4. Then, we're going to add more and more and more steps until the staircase looks exactly like the circumference of the circle. And that staircase still has a length of 4, but earlier we solved for the circle's circumference as pi. So does this mean pi equals 4? The staircase and the circle look the exact same but have different perimeters. Well, here's the truth. We're pretty much comparing apples to oranges. The paths get closer in position, but not length. Closeness of points does not equal closeness of length. Let me explain. As we have an infinite amount of step-ups and stairs on the staircase, those infinite amount of step-ups still contribute to the perimeter. It doesn't just turn into a curved line like the circle. So even though the two shapes look the same and get infinitely close in distance, the staircase doesn't magically converge into a circle or a curved line. And this means you're trying to relate two unrelated shapes and compare their perimeters, which we can't do. So don't worry, pi does not equal 4, and this is just another proof that requires us to look a little bit harder into it. So, the scariest fake proofs aren't the ones that look fake immediately, they're the ones that seem super obvious. Like for example, if I'd shown you those two proofs I did earlier, you may not have been able to recognize the error in them immediately and stumble across a really weird result. So the real skill in proofs isn't memorizing steps, it's knowing what's legal and what's not, and be able to recognize that even when it's easy to miss. Finally, remember, proofs fail where you stop questioning and when you stop scrutinizing what's really happening.